Hello everyone, just giving some feedback on last week's worksheet looking at the rectangular distribution. So just going through example of question 3 and also looking at 6 and 7 a little bit as well. So for question 3, calculated the value of k. We knew that it was going from 0 to 10. So the base of that rectangle for the rectangular distribution is 10, which means the height has got to be 1/10 or 0.1. The area under any continuous distribution is 1. So the area under the curve of a normal distribution is 1. The area in the rectangle of a rectangular distribution is 1. So the base times the height equals 1. For part B, it's asking for the probability of exactly 4. Now if you look at that line, I want it to land on exactly here. Now because that line is only one dimensional, it has no area. Okay, so that means that the probability is going to be 0. It's always 0 for a continuous distribution. It's the same with the normal. If I've got a normal distribution with a mean of 50 and a standard deviation of 3, the probability of getting exactly 51 is 0. And that same part comes up there on question 4. Probability of getting exactly 1, 0. In a continuous distribution, you cannot get an exact probability. You can get a range of values, but not an exact probability. If it was a discrete variable, discrete distribution, for example binomial, we can get exact values. But for continuous, it has to be a range of values. So that's one common mistake the students were making. Question 6, we've been given this distribution, 0.1 between -3 and 7. So I've drawn my rectangle for the rectangular distribution, going from -3 to 7. I've just put my 0 marker on there. And the height 0.1. So part A is asking what is the probability of being positive, so greater than 0. Well, it can go from 0 all the way up to 7. That gives me a length of the triangle of the rectangle of 7 and a height of 0.1. Total value 7 times 0.1, 0.7. Part B, the magnitude exceeding 2 grams. So this magnitude, these double lines, these vertical lines, x between two vertical lines, it means is the value bigger than 2, ignoring the signs. So for this one, is the value less than -2, so -2.5, -3, where those values, if we ignore the signs, are bigger than 2. And at the other end, is it bigger than 2 in the positive side? So on our rectangle, always got a rectangle for the rectangular distribution, from -3 to 7, I want this area here where it is bigger than 2 and positive, and here where the numbers, ignoring the signs, are bigger than 2. So that's from -2 to -3 in that case there. So that's got a length of 1. That's got a length of 5. Both parts are times by 0.1 to get those areas of those two separate rectangles. 0.1 plus 0.5 gives a total of 0.6. Same for part C then. Magnitude less than 4 grams. So magnitude, the value of this, regardless of the sign, is smaller than 4. So rewriting that in probability notation, the x value has to be between +4 and -4. On the diagram, well, it doesn't go down as far as -4, it only goes down to -3. So we're going to include all of that through 0 up to 4. Gives me a base of my rectangle of 7, -3 up to 4, and 7 times 0.1 is 0.7, and those were those answers there. for question 6. Question 7. A lot of students having trouble with this last question on the worksheet, and this is because it was working backwards. We were told what the mean was. We were told that the mean was 9. So what I needed to do was use the formula for the mean. How we find out the mean? Well, it's half of the first value plus the second value, the smallest value plus the biggest value. In that previous example where it was going from -3 to 7, add those two end values together, -3 plus 7, and then divide it by 2. Here, we know that the answer is 9. So half times the first value plus the second value makes it 9. Well, to undo that, I'm going to times by 2 on both sides. So a plus b equals 18. Then when we halve it, we get 9. And what were the smallest and biggest values? Well, in that probability notation, we were told that the smallest value, that those values of t, went from -b up to 4b. So the smallest value was -b, the biggest value was 4b. And if we add those together, we get 18. So a little bit of algebra, -b plus 4b, -1 plus 4, that's positive 3b, equaling to 18, which means b equals 6, divided by 3 on both sides. So that was question 7 part A. 7 part B, you didn't need to have done 7 part A to do, because we knew the answer for B already. So what I've done, over where it said 1 over 5b, I've changed that to 1 over 5 times 6. The previous answer told me that B was 6. Even if I didn't get all the marks for part A, I can still use the result in part B. And t was going from -b to 4b. So that's from -6 to 4 lots of 6. And it was 0 otherwise. So, drawing out a diagram of that, I've got a rectangle going from -6 to 24. The probability of that is 1/30th, that's the height. That length is 30. And 1/30th times those together, area is 1. That's correct. And you're being asked to find the probability of t being less than 15. Putting 15 onto my number line, going all the way down to -6, that gives me a length of 21, multiplied by 1/30th, which is the probability. 21 over 30, 7 over 10, 0.7.